Ladies and gentlemen, welcome to this episode of my editorial video series. This video is on mathematical problems and solutions on production function, and this is part 2. Like I have done in part 1, that is part 1 of mathematical problems and solutions on production function. Here too I will solve one very inclusive problem on production function through calculus, by using calculus. Now look at the whiteboard. The production function is q equals to 30L minus 30L square minus 2L cube. The production function is given by q equals to 30L square minus 2L cube. What are the requirements? A. Find out the maximum value of average productivity of labor, that is APL. B. What is the value of MPL at max APL, that is what is the value of marginal productivity of labor when APL, that is average productivity of labor, is maximum. Number C. What is the output? What is the output maximizing value of L, that is at what value of L the output is maximized. And number D. For what value of L MPL is maximum, that is at what value of L the marginal productivity of labor is maximum. Now look at the whiteboard. I am solving all these parts one by one. Solution A. It is given q equals to 30L square minus 2L cube. Therefore, APL, that is average productivity of labor, is equal to q by L, total quantity, by amount of labor, is equal to 30L square minus 2L cube divided by L, equals to 30L minus 2L square, 30L square minus 2L cube divided by L. It becomes 30L, here L square, and in denominator L square, and in numerator L, so 30L minus 2L cube by L, that is 2L square. Now APL will be maximum when DDL of APL is equal to 0. So APL, that is average productivity of labor, APL is maximum when DDL of APL is equal to 0. That is, this means DDL of Q by L equals to 0. This means DDL of 30L minus 2L square equals to 0. This means now we are differentiating 30L minus 2L square. So it becomes 30 minus 4L equals to 0. This gives us 4L equals to 30. This means L equals to 30 by 4 equals to 7.5. L equals to 7.5. Now the question is find out the maximum value of APL. Now we shall put this value of L in APL, that is 30L minus 2L square. Hence max, that is maximum APL, is equal to 30L minus 2L square, that is 30 into 7.5 minus 2 into 7.5 square. So 30 into 7.5 minus 2 into 7.5 square. Right? Now I have to use calculator to solve this part of the problem. So 30 into 7.5, 30 into 7.5, that gives us 225 equals to 225 minus 2 into 7.5 square. So we get 56.25 equals to 225 minus 2 into 56.25, 112.5. So 225 minus 112.5, so we get 112.5. So this is the maximum value of APL. This is the maximum average productivity of labor given this production function. So part A is solved. Now come to part 2. What is the value of MPL at max APL? Now we know when APL is maximum, MPL becomes equal to APL. So when APL is maximum, the value of MPL and APL will be same. So in part D, when APL is maximum, MPL is equal to APL. Therefore, MPL equals to 112.5. Right? So part B is solved. Now come to part C. What is that? What is the output maximizing value of L? Output maximizing value of L. Output is maximized when dQdL, that is differentiating Q with respect to L, that is the production function, becomes 0. That is dQdL, that is marginal productivity of labor, becomes 0. So this is output maximizing L. Output maximizing L. So we have the production function Q equals to 30L square minus 2L cube. Therefore, dQdL is equal to ddL of 30L square minus 2L cube. Now at maximum output, this will be 0. ddL of 30L square minus 12 cube equals to 0. This means 60L 30L square, it becomes 60L. DDL of 30L square is 60L and DDL of 12 cube is 6L square. So we are differentiating 30L square minus 2L cube. So DDL of 30L square is 60L and DDL of 2L cube is 6L square. Once again I am telling you that some students may be weak in calculus. I invite those students to let me know whether they need any further clarification on calculus. In that case, I shall provide you a video on calculus. Now in this video, it is not possible to teach calculus. Okay, so it is assumed that it is being understood by you. So 60L minus 6L cube equals to 0. So this means 6L square equals to 60L or 6L equals to 60. 6L square is equal to 60L, therefore 6L equals to 60. So this gives the value of L. L equals to 60 by 6 equals to 10. So when the value of L is 10, the output is maximum. So part C is also solved. Now come to part D. For what value of L, MPL is maximum? That is max MPL. Now MPL is maximum when DDL of MPL is equal to 0. Right? When APL is maximum, DDL of APL is equal to 0. When MPL is maximum, DDL of MPL will be equal to 0. Right? Now what is MPL? Q equals to 30L square minus 2L cube. Therefore dq dl equals to 60L minus 6L square. Therefore ddl of dq dl equals to ddl of 60L minus 6L square. Now at max MPL, that is at maximum marginal productivity of labor, this will be equal to 0. ddl of 60L minus 6L square will be 0. ddl of dq dl equals to 0. This means 60 minus this becomes 12L equals to 0. Right? When MPL is maximum, DDL of MPL will be 0. Now this is our MPL, 60 minus 12L. I mean 60L minus 6L square. So we are taking DDL of that, DDL of dqdl, that is DDL of 60L minus 6L square. So this becomes 60 minus 12L, that will be equal to 0. This gives us the value of L. 12L equals to 60 Therefore, AL equals to 60 divided by 12 equals to 5. So, when AL is equal to 5, the marginal productivity of labor is maximized. So, part D is also solved. So, what we have learned in this video? Our production function is given Q equals to 30L square minus 12Q, and here we are solving 4 parts. Part A, find out the maximum value of APL. Now APL is maximum when DDL of APL, that is DDL of Q by L, is 0. So APL equals to Q by L equals to 30L minus 12 square. APL is maximum when DDL of APL is equal to 0. That is DDL of Q by L equals to 0. This means DDL of 30L minus 12 square equals to 0. So we get the value of L as 7.5. So when L is 7.5, APL is maximum, and we have to find out the maximum value of APL. Now what is APL? APL is Q by L equals to 30L square minus 12Q by L. So here we have put the value of L, 7.5. Maximum APL equals to 30 into 7.5, 30 into 7.30 into L, that is 30 into 7.5 minus 2L square, 2 into 7.5 square. This gives us a value 112.5. So maximum APL is 112.5. So A is solved. Now come to problem B. What is the value of MPL at maximum APL? We know when APL is maximum, MPL becomes exactly equal to APL, and we have already found out the maximum value of APL. So that will be the value of MPL. So MPL is 112.5. That is the maximum APL. Now come to part C. What is the output maximizing value of L? Now output is maximized when dQdL becomes 0. The production function is given Q equals to 30L square minus 12Q. So we are differentiating Q with respect to L. So dQdL becomes this. Now this will be equal to 0 when output is maximized. So we have set this equal to 0, and we have found the value of L as 60 by 6 equals to 10. So when L is equal to 10, the output of the farm is maximized. Then come to part D. What is part D? For what value of L MPL is maximum? Now MPL is maximized when DDL of MPL becomes 0. So we have to differentiate dQdL, and we have to set that at 0. So the function is Q equals to 30L square minus 12Q. Therefore dQdL equals to 60L minus 6L square. Now MPL is maximum when DDL of this is equal to 0. So DDL of dQdL equals to DDL of 60L minus 6L square is 0. That is 60 minus 12L equals to 0. We have differentiated 60L minus 6L square, and we have found out the value of L as 5. So when L is 5, MPL, that is marginal productivity of labor, is maximum. So all these 4 parts are solved. Okay, I hope it is well understood by you. Still, if you have any doubt in your mind, if you think a point needs to be clarified to some greater extent, then please let me know through the comment box. I shall be more than glad to respond to all the relevant queries, relevant doubts. And if you think this video has benefited you or it is going to benefit you, then please do share this video with your friends so that they can also derive benefit by watching this video. And finally, thank you for watching this video. Goodbye and stay well.